Hello everyone. I've got this new bongo cat on my screen. I'm slow today. Search in a rotated sorted array. I think we had this problem before, but we had to find the minimum in the rotated sorted array. Okay. But first I have to solve this question, which I was doing yesterday, a day before yesterday. Yeah. So I was thinking of having a prefix tree. But let's just say our prefix tree started with the root node as -1, and it will have 9 possible branches: 0, 1, 3, 4, 5. Each will hold another node. Like in case we have in 0 we have null, but in 1 we have this whole section. And we had 0 here. So, and the array 1 1 is error 1 was 1 comma 100 comma 10, right? So for 1 I'm gonna do a DFS, sorry. So initially can convert this into a string and check each numbers, right? Starting with 100, we have we got till 1. and then there's no number left. This will be of size 1, and if we go for 100, first we go here, then 0, we will reach the end, so we'll return 1 here, return 2 here, and just return what again? We return 3 here because we found the size of the prefix as 3, and for every DFS here I can count the max depth I could find. Let's just code this up because I'm not that efficient in calculating the time complexity as of right now. So we would need a method to make a prefix tree. Okay, I'm gonna make the prefix tree from the array 2, and I is equals to int I of arr2, and convert this each number into a string arr2 dot string dot value of arr2, and I'm gonna have a root also. Root equals to new node -1. Alright, append tree will take the root as well as the num. Now for every letter in that num, example 100, 1000, first I'm gonna take one, make a node of it, assign it to current node's child's one index or this index basically, and then move forward. Okay, that could be the solution. Node current equals to root, then for char c and nums. How to convert a character into a string? Sorry, an integer. get numeric value, or I can minus it with 0. And I is c minus 0. Anyhow, we have one digit, right? So I can do it with c minus 0 to get that integer, and then current dot next nodes. I have to check if is equal to 0, then I increment, then I put the value there. Node new node equals to new node of I value, and current dot next node of I will be new node. And then I move current to next. Current equals to current dot next node of I. Okay, this will append my prefix tree. This will make my prefix tree. And then next we need to compare. For comparing, we would need a search basically. So for int in arr 1 array 1, for each number string num value of I, I'm gonna do a TFS search basically, which will give me the depth for that nums num and the root, and we will have a max length which will just compare the current depth for that particular integer with the overall maximum element which we have found. Then we return max. We will need another method for DFS which will return we will need a counter for depth, which is initially 0, and then we check if current dot next node of I equals to null. Then just we return depth. If we found that element, we go inside node of I and then depth plus plus. Huh, it's still negative. Man, oh man. But how do you calculate the time complexity of this? So instead of storing, let's solve the problem though with a prefix tree. But what was the time complexity? Initially, I did the same thing, but instead of comparing for every single element, I combined every single integer into one prefix tree so that most of the multiple overlapping prefixes in array 2, for example 1000, 1001, 1004, all have the same prefixes of 1000, as in 1 and double zeros, right? So for comparing 100 or a 10 with 1000, 1001, 1002, and for each of them, from comparing it with 10 and then 100 and 10 and then 1001, 10 and then 10004, we are doing comparison between that initial 100 and the 10 multiple times. We have cut down that. Put all the possible prefixes of each element in era 1 and hash set for all possible prefixes of elements in era to check if it in the hash set. Okay, let's try. Not most of the people know about this data structure. I want to see the hash set and prefix generation one. For every number in era to keep from full number, let's say x, keep removing last digit. Shakti Pravesh. This guy did it just like me, but we don't need the end here. It's just the prefix tree implementation has it, but we don't require this in our case. In this for this particular question, okay, he did the same thing as what I have done. Yep, it's almost identical. So what's the time complexity? Can anyone explain the time complexity here? M into depth plus. Yeah, I got that, but the depth can be 10 power 8, right? Because then. Oh shit, no. 10 power 8 is basically 8, 9 values. Oh, I understand now. Okay, let's just try the hash set approach. Let's just see how much time does it take for a hash set solution. We have we need to have a set of integer, and then we don't need int nm. Uh, iterate the error one and get all prefixes of each element for I and arr1 and x is I, for example, while x is greater than 0. We store 100, then we store 10, then we store 1. The collision is log n. So log n would only be of 10 times, depth is 10, 10, still log n. And we do this n times. This part would be log n basically. And this would be 10 power 4. Okay, n log n. This whole operation would be n log n. N log n would suffice. And then the second approach, and for checking 2, we would do the same thing, but we would have a check to stop it early when we find a longest prefix, right? Integer dot min value. Hmm. If prefixes dot contains this x, then and string dot value of x is greater than max, right? We just put the max value as string dot can have length as and we can just break and return the max. To optimize this, I can have this as a inner thing, right? If it is greater than this one, then I store it, else I break. Because if it is lower, then in no case we will get a higher value, right? Even if I find a value of 3 initially, okay, we move forward. If it is 5, then we found it at 4, we just mark as 4 and move forward. But if I find it, but it is less than this thing, then also I break. In any case, I'm breaking. Okay, the max is 0. Damn. What was the other approach? Math.log x plus 1. What was it? How to find the number of digits in an integer in Java? Math.log10. It is still slower than prefix tree though. What's the time complexity of this? Yeah, n log n and m log n. Time complexity collision and hash set. Okay, let's make a video of this question. We need to have three approaches. Sorry, two approaches which should solve it. Brute force. No, three. Okay, the question says find the long length of the longest common prefix you're given two arrays with positive integers ARR1 and ARR2, a prefix of a positive integer. Okay, so today we're going to be solving this question. Three zero four three. Find the length of the longest common prefix. Given two arrays of positive integers ARR1 and ARR2, a prefix of a positive integer is an integer formed by one or more of its digits, starting from the leftmost digit. Example 123 is a prefix of 12345. Okay, let's just copy this. What is a prefix? Example, we have a num of 1, 2, 3, 4, right? We have this. Prefixes are either 1, 1 comma 2, 1 comma 2, 3, 1, 2, 3 and 4. We have in total of 4 prefixes. This question has given us two arrays ARR1, 1, 10, 100 for example, and we are given ARR2 of 1000, 100, 1001 and 10. Alright, it wants us to return the longest common prefix. Okay, common as in between every pair integers in ARR1 and ARR2. Alright, this is 0, 1, 2. 1 2. Pairs can be 0 comma 1. This is of ARR1 and this is of ARR2, and another pair we can have 1 comma 0 comma 2 and 0 comma 0. And also we can have, if they're gonna be, total would be ARR1 dot length into ARR2 dot length number of pairs totally. Alright, and the question has also given us the constraint that each array is of length 10 power 4 and each element in the array can have the value of 10 power 8, which is 1 followed by 8 zeros. 8, right? This size is 9 digits. Why am I telling you this? For any number whose number of digits is 9, then it's gonna have 9 prefixes: 1, 10, 100, and till the end we're gonna have 9 digits. So the brute force approach would be comparing every element from ARR1 with every element of ARR2, right? Comparing this I with every value here, j and j, right? And then moving this forward again and comparing this element with every pair here. So for each pair comparison, I and j, we need to find its prefixes, right? So let's take an example. We are comparing 10 with 1001. The prefixes of 10 are 1 and 10. Prefixes of 1001 are 1, 10, 100, and 1001. These two and these three. We see this one, and this one are common, but the prefix with the longest length is of size 2, right? So we took an example here of for IS1 and 1 and if I do it for 0 and 1, anyhow we're gonna find every pairs. Let's just say I went with 0 comma 1, which are 1 and 1001. I'm gonna calculate the prefixes again. It's 1. The prefixes here are 1, 10, 100, 1001. And if I go with the pair 0 comma 2, which is 1 and 1010, right, and calculated the prefix again, we have 1, we have 1 1 0 1 0 1 1 0 1 0, right? You see how we are doing the same thing again. I calculated the prefix of this particular number for the pair of 0 comma 1, which is this one, but I also calculated the prefix of this one for every other ith value. For example, for the pair of 1 comma 1, I'm still gonna find the prefix of 1001. And for the prefix of, and if I take the pair of 2 comma 1, I'm still find the prefix of 1001. So anyhow, I know that we need to store the prefixes, right? So can I do it efficiently without restoring values? Yes, but let's just see what's the time complexity of this thing. Here, the size of the array is n and m, for example, which is 10 power 4, 10 power 4, right? And we are comparing every pair. Pair would be n into m, most obviously. And for checking, and then for each pair, getting prefixes is then again log n basically, because for a number of this size, to get a prefix, I have to divide it by 10. To get a number of this size, I have to divide by 100, 1000, and again divide by 10, 100, 1000. So if you do the math, it's just the formula of log n basically. Okay. And once I have gotten that, I need to check if they have any common values, right? Using set maybe, then the average collision would be O of n or O of 1. I'm gonna take O of 1, but even though that our time complexity comes down to O of n into m into log n, which will not suffice for constraint of less than equals to 10 power 4. We need a better approach. So just how I said that we need to store it this efficiently. How do I store it efficiently? We saw that for the integers 1, 10, 100 and 100, 1001 and 1010, their prefixes are 1, 100, 1, right? And their prefixes are 1, 100, 10, 1001, 101 and 1010, right? So let's just say I got all the prefixes of a single array, either ARR1 or either ARR2. I have stored them in a set, alright? Now, for every number here, 100, I can take its prefix 1 and check if it is available here in the set, right? If yes, then I can check if it is maximum, right? Or else I can go on with the other number. One is available, then I can check if 10 is available. Yes, 10 is also available, and 100 is also available here. Making coding videos is kind of boring explanation and stuff, I believe. Teaching is not my forte, sorry. Search in rotated sorted array. Given an integer array num sorted in ascending order with distinct values, is left rotated to an unknown index k such that the resulting array is k, k minus 1 and 0. Okay. One, two, three. Okay. Given the array nums after possible rotation and an integer target, return the index target if it is in nums or minus 1 if it is not in nums. I have to do a binary search here. If I take this example, nums is equals to 4, 5, 6, 7, 0, 1, 2, and the target is 0. This is 0, 1, 2, 3. The size of n is 7. Our low initially would be at 0, high would be at 6, would be high. Mid would be low plus high divided by 2, which is 3. If mid is target, we return mid, right? But good. But else we have two conditions. Where to check? Left side or the right side? Here in this case, our left side, the value at left index is 4 and the value at mid index is 7. They are both, your left is less than middle element. And if my target falls between this, I choose this. And there is a case here. And here is also a case where mid plus 1 is less than the value at high. Here it is 0, here it is 6. If my target falls between this, I take this part, right? But there might be a case if, for example, we had the array as 4, 5, 6, 0, 1, 2, 7, and our target was 1, for example. Low is here, high is here, our mid would be at 2. Now, the value at mid is not equals to target. Then we have two choices to go, either the left side or the right side. In the left side, we have the value at low is equals to 4 and the value at mid minus 1 as 5. Now both of these, now low is less than mid here, but my target is not between this, and in the right we have mid plus 1 and high. Mid plus 1 is 7 and high is 2. Now since this is opposite, that means we have the numbers between these two could be 7, 8, 9 and 2, or it could be 7, 0, 1, 2 till 2. It could be like this. Now here, if my target falls in this criteria, it should be mid plus 1 element would be greater than my target, and my target would either be less than the high value, right? When there is an inverse and mid is higher than the right element to the mid is higher than the highest element, then we check if the target is greater than mid plus 1 and less than this one, then we choose this. And there could be another case where let's just say our target was 4 or anything 4, and we have an array for example, and we got to a case where m minus 1 and with L, if L is greater, it is 4 and this one is smaller, example 2, then the rotation peak would be here. So in this case, the elements could be 4, 5, 0, 1, 2, or it could be 4, 0, 2, like that anyhow. So in this case, our target is greater than L here and target is less than m minus 1 here, then we choose this. So to break it down, for choosing left and right, it all depends on the relationship we have with mids left and mids right and the last element. So there could be multiple cases where is less than here. This is the simple case, and target falls between, it is greater than low, and target is less than m minus 1. We choose this left side, or either it could be L is greater than m minus 1 and target is greater than L. It's still the binary search. It's the same binary search, right? They got the metas here, then 0. Target does not fall here. Okay, I did one thing wrong. Target does not fall between any of these things anyhow. There is an inversion here. Inversion between the high and mid, right? When there is an inversion between the high and mid, then our target going to the right should be either this or the target should be less than mid. But if we had an inversion here, for example, if we had 3, 4, 0, 1, 2, 1, 2, 3, no inversion. When no inversion, we can just check if target falls between these two extremes, right? Anyhow, the value of low should be less than equals to mid, and it should be less than equal to high. But here in this case, low and mid our mid is greater. Sorry, the mid is smaller. There's an inversion. So any target to be here, the target should be greater than L, or the target should be less than mid. So I got it. The cases are when then we have to check if in case value of mid is not equals to target, then if we see that low is less than equal to mid, then we can check if target falls between them. We can take left side, or in case L is greater than mid, then it is rotated between these two. Then we only check if there's two conditions there now. If target is greater than lower, or mid is greater than target. If any of these true, then we go left again. Third case would be right is, sorry, high is greater than mid, and target falls between these. Then we go right, or else high is less than mid. Then there's an inversion again. I can just go on and start implementing this. Int n is equals to nums dot length. We have int l is equals to 0, h is n minus 1, while l is low is less than high, and m is l plus h divided by 2. Then we have case 1 to check the left side. Nums of l is less than nums of m. Then we check if target is greater than nums of l and target is less than nums of mid. Then we choose this side. The initial case would be if nums of m equals to target, we just return m, else if r high becomes mid, else if nums of l is greater than nums of mid. There's an inversion in between. This is higher than the mid value. Then if target is greater than nums of l, or target is less than nums of m, Or what if I had values like this? Target is 5. Okay, clearly mid is not equals to target here, and low is greater than high. Then if target is greater than L, choose left. If Because if it is greater than L means it would be here only, we cannot be there. But that only happens if L is greater than M mid and mid is less than L, right? Okay, there I can put this conditions as here as well. If low is greater than mid and mid is less than high, then between these two is rotated. So the highest value could be roaming around here, right? Only if the value is greater than high. But if the value is, for example, 3, but whatever I'm doing is correct here only. Thank you. Else, if This was lower and the middle one was higher. Nums of H is lower than nums of mid. Then for it to be on the right side, it should be either greater than mid or it should be either less than. This will not work. Really, thank you. Really again. Why? Uh, just do a dry run. If I had the array as 4, 6, 0, 1, 2, 3, size is 6, and the target is, for example, 6. low and high here. Low is 4 and high is 3. Mid is 0 here. In this scenario, low is greater than mid and mid is less than high also. So that means I don't know. I have no idea. That means what? Okay, that means RM is the minimum. Okay, because if we had 0 over here, then obviously 6 would be here. Then less would not, L would not have been lower than M. So for this case here, I see my target is greater than L and target is even greater than H and target is greater than M. In any case, it is rotated. That means L is automatically greater than L anyhow to be rotated. If it is rotated, example, and our target is greater than mid, then obviously it's on the left side. And if it is not rotated, okay, if it is rotated, then L is greater than H, and we see target is greater than mid. If, for example, this was 4, yeah, L is greater than H means it is rotated and the target is greater than mid, then left side, left half, as in. But what if target is less than mid? But then also it could be on the left side. When do I choose left and when do I choose right? For example, if we add 40, sorry, 6, 0, 1, 2, 3, and 4. This is L, this is H, this is middle. In this case, if I choose the target to be 6 only, here it is ascending, here it is ascending, and here it is descending and ascending again. Okay, I'm losing my brain cells on Leetcode. Why do I have to Leetcode so much? Our target is still 6 here, but here the low is greater than high and mid is still like this, which we had seen here also. In here, this is rotated and middle is less than high. Then we check if it is present here. No. Target is greater than h. I take this half. This becomes my new low, and this becomes my new high, and the mid would be this one. We found it. What was the example in here? 4567012. We had 4567012. 0 1 2 3 4 5 6. Low high. Here initially I see low is greater than high. That means it is rotated, and mid is here, and mid is greater than high. That means rotated part is at right. So I check between low and mid. Target was, what was target? 0. Okay. Target does not fall between here. Then we go to the right. Our low is this one now. Then in here 9 by 2 is 4, that is 8. I'm gonna get it in 1 second. Low here, I still stays there 10 by 5. M is here. Now I see low is less than high. It is normal binary search. When it is normal binary search, we check only if target is less than mid or target is greater than mid. Based on that, I move my left and right. So I've gotten here. Yeah, let's just do it. Then there could be two cases where it is rotated there or it is rotated there. If nums of L is less than nums of M less than equal to, and let's just see the solution, man. Man, oh man. I was doing the same thing. I was doing the same. Let's just do it again. If this is smaller than this, it is rotated on the right side. Alright, if L is less than M, then if the target is not between this, if it is between this, then our high is mid, else our low is mid plus 1. Okay, alright. else this is rotated this side, then obviously our m is less than high. Then we check if nums of mid is less than equals to target and target is less than equal to num of high, then our low is mid plus 1, else our high is mid. In any case, return -1. If this goes to TLA, I don't know what I'm gonna do. It went to TLA. It accepted. Wow. He got the wrong answer here. I didn't put this case. Alright. It got accepted. 2 hours wasted successfully for the day. Nice work done.